So we can theoretically get this done fairly quickly. We are going to do just this page today. This is one of those things that is going to come up again. There are questions about this on the final that we'll take in the spring. There's questions about this stuff that'll be on the final we take this semester. There's questions about this stuff that'll be on the project that we do for this chapter. So what we're doing today is going to show up on a lot of things. So what we're going to start with is this picture on page 106. We have this picture it's in your workbook right here. And the first thing we need to know are what are the dimensions of the drawing. Meaning I need the actual physical measurements of the picture in your book. So make sure you're being careful when we're reading. We're going to use inches. Make a note that the little lines on inches are not tenths. It's not tenths. It's all divisions in half. So it's half, or eighth, or quarter, or 16th. So we want to measure this picture width and length. So we want to know how wide the picture is. That's what we're talking about when we say width. And we want to know how tall this picture is. Length, depth, whatever dimension you use that as. Probably length, but they usually say depth. So when I do this, I get width. And this would be length or depth, either way. So physically, we're going to grab a ruler. We are going to measure the picture on the page in front of us. To the nearest eighth of an inch, as close as we can be. I don't have a giant ruler I can put up on the screen that would be the same scale. I wish it did. Not quite. Let's see, do I have? Let me see if I can make the ruler be the same scale, but I don't know if I can. Nope, it will not. Oh, it is actually just about the same scale. Almost. No, it's right on. All right, so if we were to grab our ruler and line it up, this is pretty close. It's not perfect, but it's pretty close. Measuring it out. Make sure you use your inches. So how wide is this picture? What is the width of our picture here? We got 2 whole inches for sure, because that's here. But we don't get quite all the way to 3. This is 2, and this one is 3. 3's all the way over there. So when we're working with inches, remember that these are always cutting in halves. So this tall line in the middle would be at the half. Say, if I take that in half again, that would be this guy. So this would be 3/4, which is close. But it would be really helpful if I had one more little chunk. That's really, really close. That would get us. So if I cut quarters, fourths in half. So this would be another 4th. That would be our 1/4. What's half of 1/4? That would be if I had 2 sets of 1/4. Half of 1/4. So, pizza, cut it in fourths, right? Each of these is 1/4. What would half of 1/4 be? How many pieces would that divide it into? 8. So it would be 1/8 in between. So these second smallest lines are 1/8. So we are one little bitty line away from 3. So I don't have 8/8. That would get us all the way up to 3. I have 1 less. So this is going to be 2 7/8. Because this would be 1/8 2/8, 3/8, 4/8, also known as 1/2, 5/8, 6/8, 7/8. So the closest we can get is about 2 7/8. We're going to do the same kind of deal looking at our height. So we'll take our ruler and we will rotate it and do the same kind of deal. But we want to make sure we go the whole height. I'm going to rotate my ruler the other way just because then all my marks are on the other side of the board. Oh, and it helps if I line it up with inches, not with centimeters. Yeah. This one winds up pretty much right at 3 1/4. So I started at 0, 3, that one's our half, so our 1/4 is right in the middle. So this is about 3 1/4. So the depth or the length on this is going to be 3 1/4 inches. A lot of times on these pictures, we won't write out the word inch. We just put these little they look like quotation marks, little dashes. All right, whoever's got music on, that's really rude to listen to right now. And a lot of times with these pictures, we won't be handed, okay, your width is this, your length is that. I'm gonna hide the ruler. What we're given is the dimensions. So it'll say this picture is 2 7/8 by 3 1/4. Or they'll just say 2 7/8 by, and they'll usually use an X or a little cross, 3 1/4. That's going to be how the dimensions get listed to us most frequently, either with the word inches or with these two little dash marks. Those mean inches. They're pretty little, so we use a little inch. So measuring accurately is really important for when, especially when we're looking at a picture. So, yeah, you want to see a second. The next thing we want to do is we're told a little bit of information. So on this real life house, they actually went and measured this width because they have this nice clear shot where there's no walls in the way. So they measured this and they found out that this dimension in the real world is about 600 inches. So that blue line in the real world is 600 inches. We want to see if we can figure out how many inches in the real world the green line is. So think about that for a second. See if we can figure out the real world measurement for that green line. So we can do this using our kind of unit conversion style stuff. We can set this up using similar ratios. We can do this in a few different ways. I feel like the most kind of reliable way to do this is to set up our similar ratios. I know that 600 inches in the real world is represented by that 2 7/8. That is how we drew this picture. 2 7/8 inches. I want to know what number needs to be on the top here. This is what we're trying to figure out. This is what we don't know, the real world inches for my 3 1/4 inches. If we use this same scale on both sides, which we should, if we use the same dimensions on both sides, what we can do is we can actually set these up as similar ratios. That's a question mark. Oh, it's like a quotation mark. It just means inches. It just looks like a quotation mark. Sorry, it took me a minute to read what you meant by all of it. Yeah, no, a lot of times inches are just abbreviated as a quotation mark. So when we're setting this up, we can solve this in a lot of different ways. And in fact, if you don't like having a question mark there, you can replace it with a letter. I could put X for a variable of things we don't know. I could put length for the side of the room that we don't know. I could put depth because that's what they're calling this direction of the house. I could put my initials because it genuinely doesn't matter. I could use a happy face. I could use a heart. I could use a question mark. It doesn't matter. It's a variable. It's something I don't know. We can use whatever term we want. Usually we're fairly comfortable with X. So how could we try and solve similar fraction kind of dealios? How could I try and figure out what X would be? How many inches it would represent? How could I get X by itself? How do we get rid of a denominator? Because I got a fraction here. I'd really like to know what X is. How do I get rid of that denominator? So you can go for the full. You could go for a full butterfly method. Again, I can't check out, guys. We got finals coming up in 3 weeks. 3 weeks. Finals over everything the whole semester. So we can either use the full butterfly into a cross multiply situation. I can multiply both sides by both denominators to get rid of those denominators. I could go, well, all I need is the X and multiply both sides by 3 1/4 to get X by itself. We are trying to figure out what this number is. What number would be on top of this fraction if these things are set up the same, because they should be, because that's what it means to be a scale drawing. So what I can do is I'm going to multiply both sides by 3 1/4 or 3.25. And that's going to cause my denominators to cancel out. 3 1/4. So you can either multiply with the mixed number. You can switch our mixed numbers to be decimals. You can put them as improper fractions. You can find the, I can type a mixed number into the calculator button on the calculator, which it does have. But if I show you all of those things at the exact same time, we're going to get real mixed up. So see if we can figure out what this X is going to equal. I want you to do it. X equals. See what we can come up with. We got 600 in the real world with our 2 7/8. What do we get? What should our X be? Then at least we can do it 600 divided by 2 7/8. Two and 7/8, also known as 2.875. So if it helps, you can switch these to be decimals. You could 100% write this as our 600 over 2.875. That's what that is as a decimal. And our 3 1/4, that's 3.25. You can work it as decimals. That's totally fine. If that's easier for you to do that. If that's easier for you to do that. Whichever way makes more sense for your brain. 600 divided by 2.875 and then times 3 1/4. What do we get for x? Hit the little 2 arrows above the enter key so that we can get it as a decimal. 678.26, 0.275, depending on where we round things. So I'm going to go ahead and take that as 678 just so that we keep it easier. So keeping it to the nearest inch. 678 inches. Which makes sense if we think about it, because this was our smaller dimension. This is almost 3 inches, 2 7/8, and it was about 600 inches. 3 1/4, so it's a little bit longer, almost half an inch longer, and we get 678, so it is a little bit more space. So using one dimension of my house, I only actually had to physically measure one side of the house. I didn't have to try and figure out how to measure through and around these walls, how many pieces this is, whatever that is. I can use this one dimension that is easier to measure here because there's no walls in the way, and I can find the dimension that direction. That's going to lead us into actually writing our scale the correct way. Because when we are looking at scale drawings or scale pictures or scaled objects of any kind, including things like maps, they actually have a scale on here, not just that you can measure an inch and find 20 miles, but an actual physical scale like how this shows us 6 inches or 2 7/8 inches goes to 600 inches. There's a special way of writing it that we're going to do next. So the scale of a map is written in a very specific way. It's always going to be written as 1 to something, and it looks kind of like odds when they give you your lottery tickets. Like 1 to 4 chance of winning, 1 to 8 chance, 1 in 500 chance. And what that's saying is if all things are measured the same, 1 inch on this picture is going to make some number of inches in real life. It is converting to the same thing. On the, let's see, this Bay Area map right here, it's written really, really small, but it's right above this scale here. It says 1 to 544,896. So what that tells me is 1 inch on this picture is actually 544,000 inches. 1 foot on this picture, so I measure this way, 1 foot, would be 44,865 feet. So one unit on this picture is going to be that exact scale for the whole picture. So with this drawing, what we're going to do is we're going to take the information we have. We know that our 600 inches in real life was related to our 2.875 inches on the drawing. We know our 678 inches in real life is related to our 3 1/4, 3.25 inches on the drawing. I want to know what number of inches in real life relates to 1 inch on our drawing. So you can set up either another set of similar fractions. We can simplify one of these fractions to get there, but I want to know what number would go here. You can use either one of these ratios to figure it out. We should get the same ratio either way. So we need to know how many inches on the real house that we have 1 inch on the picture is going to represent. Because remember, that ruler, where'd it go? There it is. So 1 inch is going to be like the width of this room. So what we're able to find is basically the width of this one room. Or I could say, well, if I know 1 inch, I'm going to know how far this couch is. I'm going to be able to tell how big the table is or how big this bathroom is. That one measures an inch. So we want to know 1 inch on the picture is going to stand for how many inches in real life. That couch is 3/4 of an inch. So we could use it to find these kinds of measurements. So see if we can set up a ratio. You can either do this as like a conversion or you can set it up as our similar ratios. But we need to figure out how many inches on the picture is how many inches in real life. Yeah. If we set this up as a similar ratio, I can either do my 600 over 2.875 or 2 3/4 equals x over 1, or I can take this guy and set it equal to x over 1. I can solve this around. I want to try and figure out what x is. So if we set these up here, what we're going to get is, really, we just kind of need to simplify these fractions. I'm going to type it in the calculator, and we're going to get, depending on where we round things, about 208.6. So let's go with 209. So in the real world, 1 inch on this picture, so again, that was about the length of this bathroom over here. This is about 1 inch on this ruler here. 1 inch on this is about 200 inches, about 209 inches. So the way we write this scale, we say 1 to 209. So that means whatever I'm using to measure on the picture is 209 bigger in real life. If I use centimeters, still will convert. So this rug being 1 centimeter long right here, in the real world it's 209 centimeters. If I use it with inches, this wall is about 1 inch, it's going to be 209 inches. If I use it with feet, if I could measure 1 foot on this picture, it would be 209 feet in the real world. So scale is not written in a particular unit. This is convertible to everything. So if we look at the maps, that's why on all of these maps, that's why we didn't use it when we were looking at things, there's several 100,000. Some of them over 1 million. This Denver one is 1 inch on here, is 823,680 inches in real life. For the state of Colorado here, it's 1.7 million. So 1 inch on here is 1.7 million inches. Which is why we don't use scale when we're coming to maps very frequently, because holy cow, is that a lot. That'll be used a lot more for things like blueprints or plans or house plans. So the last piece we have to do with this is we're going to find our area for this house in 2 different units. We know our width of our house was our 600 inches. That's what we were told at the beginning. And we found the other dimension. I could say that this house is 600 by 678 inches. We found our drawing was 2 7/8 by 3 1/4. This is 600 by 678. So we could find our width and our length, and I can use that to find the area. We want to find it both in square inches and in square feet. That's our last part for today. So we have 2 questions left. One of them's got 2 parts. And that's it. So if we finish this out, I'll stop talking at you. So the first thing we want to know is our area in square inches. How can I find my area with those 2 numbers? what is our area going to be? If we're feeling shy, the next thing I'm going to ask, how many feet is this? I'm going to ask, how many feet is this? And we're going to find our area in square feet. So if you think you've got our square inches and you don't feel like saying them out loud, convert it to feet. We're going to find square feet too. How do we find the area? Multiply. So 600 times 678 is going to tell us what? What number to get? 406,800. And those were both in inches, so this area becomes square inches, 4 inches squared. So we found the square inches, which is great, super awesome, love it. Only really helpful if I am ordering square inch tiles, meaning itty bitty bitty little baby tiles. I would need to order 406,000 itty bitty 1 inch tiles. I don't want to tile my house in 1 inch tiles. That's a lot. Ew. So more often than not, we're going to need this in feet, square feet. I could convert 406,800 into square feet using my conversions that we've worked with, how I know 12 inches is a foot, but if I have square inches, then I'm going to have to square things. That works. But usually we're a little more comfortable taking our dimensions and changing them. So if I know that 600 inches is the width of the picture, how many feet would that be? If I just change my 600 inches to feet. How would we change that? If I want 600 inches and I want to change that to be feet, I need inches to cancel out. What do we know about feet and inches? How many inches in a foot? 12. Inches in 1 foot. So we can use those similar ratios still. We can still use our unit conversion kind of problems here. Because we're taking our 600 inches and we're going to divide it into 12-inch chunks. We're going to divide it into feet. So what is 600 divided by 12? 50. So the width of this house is about 50 feet. But you can put the FT for feet, or inches are little, so there's 2. Feet is just 1. So more often than not, the little dash is foot. So then we need our other dimension. I had 678 inches. What is that in feet? 56.5. So what is our area in square feet? (2,825) square feet. Feet squared. So when we're finding area, we multiply our length times our width. So we're going to work with those pieces. Scale is all about 1 inch on the picture is how many inches in real life. They are always talking about the same unit. Scale can only be written in the same unit. I can set up similar fractions with all kinds of different units. These have to be using the same one. Have to. I can't do 1 inch to 2 feet. I have to do 1 inch to 48 inches. or 24 inches. Okay, so we have about 10 minutes to the end of the period. I'm not giving you another homework assignment right now. We've got 2 from this chapter. I know some of us still have some things to catch up on. We are zombies. Real hard. I know the senioritis is senioritising. We got 3 weeks till finals. Don't give up yet. We still got things to do.